Aging and disease are biochemical processes that happen over many decades. So if we track well-established biomarkers of organ and systemic health, can aging and disease risk be slowed? So with that in mind, earlier this month, I blood tested for the third time in 2022. So what's my biological age? And we can see that data here. This is using Dr. Morgan Levine's phenotypic age calculator as an index of biological age. And what we can see is that my biological age is 35.3, which is 14 years younger than my chronological age of 49.3. Now, note that Quest's high-sensitivity C-reactive protein measurement was less than 0.3 milligrams per liter. So CRP could be somewhere less than 0.3, anywhere in the 0 to 0.3 range. But it can't be higher than 0.3, which is what I entered for this test. Now, note that if you're interested in seeing screenshots of the actual lab report rather than me entering the numbers, all of the blood test data will be included at the end of the video. And if you have your own biomarker data, I'll include a link to PhenoAge, a free link that you can calculate it on your own, and that'll be in the video's description. The link to that will be in the video's description. So a question that I get a lot is, how good is Levine's biological age calculator? Levine's test is strongly correlated with chronological age, as you can see by the image, where we're looking at phenotypic age on the y-axis plotted against chronological age. And what we can see is an almost perfectly linear correlation between biological age using Levine's test with chronological age. So a perfectly linear correlation is a correlation coefficient of 1.0. So in two separate studies, the correlation for Levine's test with chronological age was 0.94 in NHANES 3, which included about 10,000 subjects, and in a separate study, that correlation was 0.96 in NHANES 4, which included more than 11,000 subjects. Now, Levine's test isn't just strongly correlated with chronological age, it's also associated with all-cause mortality risk. And more specifically, for every 1 year biological age increase using Levine's test, all-cause mortality risk increases by 9%. So we want to have more youthful biological ages using this test in order to have a reduced risk of death for all causes. Now, another question that often arises is, how does Levine test compare with the best epigenetic clocks for its correlation with chronological age? So the best performing epigenetic clock for its prediction of chronological age is the Horvath test. And we can see that here when looking at epigenetic age on the y-axis plotted against chronological age. And this is a multi-tissue epigenetic age clock that included cells from the breast, cheek cells, brain, colon, blood, skin, etc. You can see the list on the right. Nonetheless, we can see that it's an almost perfectly linear correlation, the epigenetic test, Horvath's epigenetic test with chronological age, with a correlation coefficient of 0.94, which is very similar to the Levine's test, which uses the blood-based biomarkers. So to answer that question, Levine's test is as good as the best epigenetic clock, Horvath's test, for predicting chronological age. Now note that this is only data for one blood test. So it's important to have more context and see how test number 3 results compare against previous data. So let's have a look at biological age results since 2020. And that's what we can see here. So first, in 2020, I measured 6 times, 6 separate blood tests, and we can see that my biological age using Levine's test was 35.6 years. Similarly, in 2021, over 6 tests, also an average age of 35.6 years. So what about 2022? So that's what we can see with the green dots. And after 3 tests so far in 2022, my average is less at 34.4 years. So I'm off to a good start in terms of Levine's test biological age. Now note that prior to 2022, so prior to these 3 blood tests in 2022, my average biological age reduction relative to chronological age was about 12 years, 11.9 years to be exact. And that's over 15 tests from 2018 to 2021. But in 2022, so far, the reduction for biological age subtracted from chronological age, for test number 1, it was 16.4 years, test number 2, 13.5, and test number 3, 13.6, for an average reduction so far in 2022 of 14.5 years. So I've been able to reduce my Levine's test biological age by an average of an extra 2.6 years so far in 2022. Let's see if I can keep it up for the remainder of 2022. Now, note that PhenoAge includes chronological age in its model, which limits the maximum biological age reduction. For example, if you're 60 years old and all of your biomarkers are youthful, or what's found in youth, at best, the Levine test will only show you as about 40. So in contrast, Aging.ai does not include chronological age in its model, so greater reductions for biological age are possible. So before showing you my Aging.ai 3.0 data, How good is this test for its prediction of chronological age and its association with all-cause mortality risk? Is it? So first, we can see that the correlation for Aging.ai's 19 biomarkers with chronological age is 0.8, which is a little bit worse than Levine's test, but it's still pretty good. It's still considered a strong correlation. So what about all-cause mortality risk? Well, a relatively younger Aging.ai age in this paper was shown to be significantly associated with a reduced all-cause mortality risk. So again, we want to have more youthful biological ages using both these tests, at least based on the all-cause mortality data. All right, so what about my data for this test? What's my biological age? So when using the 19 biomarkers and entering that data, as you can see there, Aging.ai gives me a predicted age of 32 years, which is 17.3 years younger than my chronological. All right, so just like we did for Levine's test, let's have a little bit more context by looking at previous data for Aging.ai age. Now, I have a lot more data for Aging.ai age as I've been measuring most of these biomarkers since at least 2009. In contrast with the Levine's test, which includes high sensitivity C-reactive protein, that's not a commonly performed test. You'd have to ask your doctor to order that. So I have a lot more data for Aging.ai because it doesn't include CRP. So starting from 2009, I was measuring about once a year, just going to my doctor, just the yearly physical, and then recording that data in an Excel spreadsheet. So from 2009 to 2013, over that period, I have 3 blood tests, and my average Aging.ai age was 32 years. And then in 2016, I decided to test more often, as you can see by all the dots. And over the 6-year period from 2016 to 2021, I have 27 blood tests. And over those 27 blood tests, my average Aging.ai age is 29.9 years. All right, so what about 2022? So far, over those 3 blood test measurements, my average Aging.ai age is 28.7. So that's also lower than my 29.9 over the 6-year period starting from 2016, and also better than the 3 tests from 2009 to 2013. So hopefully I can keep it up for the rest of the year and going forward. All right, so what's contributing to these biological age reductions? Supplements, fitness, and or diet. And in the interest of time, that'll be in the next few videos. All right, that's all for now. If you're interested in more about my attempts to biohack aging, check us out on Patreon. Thanks for watching. I hope that you enjoyed the video. Have a great day.